Next.js is a complex beast, but it is getting simpler. I know that sounds a bit contradictory in a video titled The Magic Powering Next. Like, isn't whole magic just hidden complexity? Kind of. But what if one of these magic things is actually just how JavaScript works? And on top of that, if this magic thing could make a lot of the other magic that you were doing before go away, so everything is much simpler in the end. That's where we're going. And before we get there, I'm going to drop a bit of a spoiler. This is the code that does it. If you can read this code and confidently immediately know what it's actually doing, hit me up. I'm not hiring, but you should get a job. I even made a joke when I first saw this at the event. I took a photo of the screen and said, I'm going to start asking engineers to describe what this code does in interviews. It's complex. It's absurd. It's scary. And it's not code you as a developer should ever have to write. This isn't code for you. This is framework code. And it's framework code that empowers some really, really cool stuff. I want to break down what this is, why it's needed, and why it's such a cool hack. But before we do that, let's quickly hear a word from today's sponsor. Today's sponsor is Bolt.new, the best way to spin up your new app. We can take a quick, wait, what is this? Bolt.diy? Turns out StackBlitz wants to support the community as best they can. And with Bolt.new being fully open source, a fork happened that lets you use whatever models and LLMs you want to use. And that fork, Bolt.diy, is now hosted by them, and they're contributing, funding, and helping it however they can. It's awesome that this is an open source project because the actual experience using Bolt is incredible. You can generate a starting point using any framework from Next to Vite to Astro. Just tell it what you want and how you want it. It'll generate it, give you a full code editor in the browser because it's StackBlitz, and a one-click deploy button, and as of recently, a one-click Supabase button. So you can set everything up on Supabase directly. How cool is that? Check out Bolt.new today at soydev.link/bolt. So I could dive straight into the talk, but this talk was for people who were very, very deep. And even I had to ask questions after to make sure I fully got it. So instead, we're going to Excalibur it up a bit. And we're going to start with a somewhat familiar topic, partial pre-rendering. Let's say this is our website. Our website has top nav, has a sidebar, and it has, product images. Maybe it has a little description. We have some more nonsense over here, whatever. You get the idea. But we have in the corner here our brand. And then up in this corner here, we have something that's user specific. We'll say this is your profile picture, your signed in thing. And maybe you have a cart up here too. So I'll put your cart as a diamond here. Very real looking website, right? I'm a very skilled mock artist. In traditional server-side rendering, a page like this would have to be rendered on the server. So you would have the user's request go to your server. The server would check which URL you're trying to go to. See, you're trying to go to, this shouldn't be description. We'll say product 17. We're going to website.com/product 17. The server gets this URL. It sees that you're trying to go to it. It has access to your cookies, to all these other things. And then based on your cookies, your headers, and the URL you're trying to get to, it generates HTML that it sends to you when it's done. But let's say some parts of this are slower than other parts. Let's say everything here, like the top bar and the sidebar, are static, so they can be rendered immediately. But we need to fetch this data from database, and we need to get this data from somewhere else to get this auth data. When you render this traditionally, you have to wait for all of those things to happen before the user gets any result. I'm going to make a mock app for this because of who I am as a person. Let's say you have this beautiful website that has these 3 slow components. This one takes a second, this one takes 2 seconds, and this one takes 5 seconds. And I did that just by blocking on a promise and then rendering it. If I go to this web page, I'm just going to copy the URL, close, and reopen it. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. There we go. It takes 5 seconds before you see anything because, as mentioned before, the server has to generate the whole page before you can see anything. This is how websites have worked for most of time. The slowest thing on the web page is the thing that blocks you from getting a response. So if any one part of your site is slow, it doesn't matter how fast the rest is, the user doesn't see anything until all of the things have loaded. But that's not how React works. At least that's not how React on the client side has worked. If we go to a website that you should probably be going to more, Twitch, to watch my live streams. By the way, I film all of these live on Wednesday. So if you're curious about how I film my videos, twitch.tv/Theo. So this web page is interesting because if I go here and I look at the HTML, There's a lot going on here. If I just like inspect here, obviously there's a ton going on in the HTML. But if I go to the network tab, refresh the page, and grab the HTML that was sent, so I just kill this one giant script tag as a bunch of data. It's only like 600 lines, and even then it's still mostly script tag. The actual HTML that you load from the server when you load Twitch is almost nothing. I'm going to delete everything in here that isn't HTML really quick. There's actually only about 40 lines of HTML that you load from Twitch, because the way that Twitch works is the server doesn't block you from loading a page. When you load Twitch with JavaScript disabled, this is what you get. An empty scaffolded loading page with a spinner, because all of the behavior on the Twitch site comes from the JavaScript. And once the user has loaded the JS, the user's device through the browser can go make all the API requests to get all the data that it wants. But that means that the user gets this loading state initially, and then they have to download the JS, parse the JS, run the JS, figure out which APIs to hit all those APIs, realize they need different JS to parse the APIs, go fetch that, load it all in, and then you start to see components. So there's a lot of back and forth, but it does actually feel better than the old way of doing things, which sounds super counterintuitive because it is. The reason this is good is because when you load the URL or you click a link, stuff happens immediately, because the amount of time it takes for the server to send you this HTML is nearly zero, because it doesn't have to check anything. It can just blindly send you this HTML because it doesn't have to generate it. It already exists. It's super simple, minimal HTML. They just spit out as soon as they can. That HTML has the JS tags that you then go and load, and then you hit the APIs. That might be fast, might be slow, whatever. But now on the user's device, you get to choose what shows up when. So if I re-enable JavaScript, but I also slow down the network speeds a ton, let's say we go down to like slow 4G, and we reload, you'll see different things pop in at different times because different things take more time to respond. So this is good. In some ways it's better, but in other ways it's worse, because now you have to run JavaScript. You have to go hit all these different APIs yourself. You have to have every potential permutation of the UI coming from the server. That was obviously not ideal, which is why Next.js moved to an SSR model, where by default, Next.js would render your React page once, get as much of the HTML as they could get, and then send that to the user instead. So in the case where there's no APIs being hit, you get back much better HTML. In the case where there are APIs being hit, you can sneak in a loading spinner and put some other things here and there, and it worked okay. But what if this was more dynamic? What if instead of it being the traditional page load on the server, and then the React JavaScript code picks up what's left after, what if the server could send down what's ready instantaneously and send the rest in later on? That's what the cool streaming stuff in the new React Next model enables. So if we wanted to wait till these two components were done, but we didn't want to wait till this one was done, I can add a suspense here. And the suspense tag can wrap the slowest component. And now when I go to localhost 3000, it's only going to take 2 seconds, and the third one will be loading until it's done. And if I want the page to come back immediately, I can wrap all of these. And now it loads instantaneously, and these pop in when they're ready. What's even cooler is this isn't code on your device that is running to go fetch those other things. This all comes back as part of the initial request. These pieces of content are streamed to the end of the HTML and then get applied where they belong in the UI, which means we don't have to wait for the slowest part. We don't have to wait for any part. We can send an update to the user immediately. But we're not even getting to the coolest part yet, because this still requires that your server starts processing before the user gets back a response. So if you have things like a database connection that takes a while, or your server is far away from the user, it takes a long time for the user to start getting a response, because the first byte back and forth is just too high. The solution for that has historically been CDNs, and that's part of why Twitch feels so fast, because all of the Twitch HTML is stored in CDNs. And when you build in the single page app way, you have a really small minimal HTML file being hosted on a CDN that's distributed around the world so people can load that part immediately. Then the rest takes a lot longer, but at least you get to see something. And that's something you'll learn as you build more and more apps. The sooner a user can see something as a result of their click, the faster it feels. Even if you had a service that when you click something, it shows you a loading page immediately and it takes 2 seconds for the content to appear versus a page that doesn't show loading and the content only takes a second to appear. The slow one, the one that's twice as slow, will feel faster because when the user clicks, they get a response immediately. So this model kind of sucks because even if you can stream down the slow parts, the fast parts are still slower than if they were on a CDN. And this is where partial pre-rendering comes in. So we currently have these suspense wrappers on the slow parts. But what if we inverse it? What if we take the parts that don't take time at all, like the shell? Let's make the shell a little more useful first. We'll hop in here, and in the body, we'll put a little h1, class name equals, you know what? We'll do something a little bit nicer. Quick cursor plug. Make me a top nav for this website. It's titled PPR is cool. So we have this fake top nav. We got these fake little links in the corner that my face is covering. Feels like a real website. Not really, but you get the point. This part doesn't have any data blocking it. We know that because if we go here, there's no await call. There's nothing here that should keep this from always being the same. So why can't it always be the same? Why do I have to wait for my server to spin up before the user can get these static parts? How can we get this to them faster? This is where partial pre-rendering comes in. I'm going to go turn it on. When you have partial pre-rendering on, things get interesting. I just removed these 2 suspense calls that were wrapping the 1000 and 2000 millisecond components. So we just have the one for the 5000 millisecond component now. And if I refresh, the page is taking its time. You can see that little loading thing up top because it still has to block for 2 seconds before we get anything. But this is what makes partial pre-rendering so dope. If we add a loading TSX, export default function loading, return loading here, now, if I'll prove it just by closing this tab and reopening it, we get it back immediately. And we get a loading state for the page load, and then we get a separate one for this much slower part. So we get granular control of what loads when, as well as the ability to have something static come in initially. What's really cool here is if we have a platform like Vercel or Netlify that can understand partial pre-rendering, is it can take that static HTML that is the first thing the user sees and then throw that on a CDN. So the user will immediately see the loading shell state, and then the rest gets streamed in once the server has spun up and is ready. You're offloading when all of that work has to happen, and you're getting the user back a response much faster without the compromises of loading a shitload of JS on the client and then going to fetch it from random APIs. It's really a best of both worlds, but it came with a lot of gotchas. The big ones were, how do we know what can or can't be statically rendered? When do we know where the boundary of dynamic starts or ends? So if we draw a diagram here, we've all hopefully seen like React Virtual DOM. That the React Virtual DOM is this tree of your components. So we could say here I have my like app component, and in app we have top nav, but we also have, I should name the page something. That's named home already. Cool, perfect. We also have home. And in home we have, I know we have 3, but I'm just going to put 2 slow components. So right now, our React app looks roughly like this. I'm going to start doing some painting. We know that app and top nav are effectively static. So this part can be cached. What about this part, though? Can we cache this? How do we know if we can cache this? How do we know if we can cache this or this? How do we know where effectively the boundary exists? Where is the line where from here down we have to cut and put everything above or below? Previously, with the early example, we'd write the boundary with suspense. But this isn't just a suspense problem anymore because we need to be able to cache in multiple depths in multiple places. You could even theoretically wrap this whole thing in suspense. I put this here instead and get all of it under one loading spinner. That works. And that will work with traditional PPR, where I could kill the loading TSX file and just have that suspense wrapper here and it all comes through together. These are all options. But wouldn't it be nice if the compiler and the framework could know when things become dynamic and when they're not? Wouldn't it be great if Next was magically able to know, hey, these things are dynamic, these things aren't? Guillermo made a demo a while back showing how powerful these primitives are, where you would load a random 12 Pokemon and the page instantly loads whenever you refresh it, but the Pokemon all come in after. All render from the edge on every request. So this has to be dynamic. If he had just awaited the data and not wrapped it in a suspense, or even if he did wrap it in a suspense, we have no way of knowing that this should be different on every render. The solution used to be a bit of magic. See this headers call in the home component? This is what Guillermo had to do and what a lot of us Next devs had to do in these demos to show what is or isn't dynamic. This is effectively painting this function, this home function, as dynamic and saying, hey, Next, this needs to be done dynamically on every request. Don't cache this. Don't hold on to this. Don't let this be part of the CDN like body or tree. This piece has to be dynamic. But what if there was a better way? What if something else in here could indicate that this should be dynamic? I would argue there is something. This word, async. Async effectively tells you that this is doing some I/O. It's waiting for something, it's doing something. What if we just cut off when you hit an async? What if everything before the first async could be cached and everything after it couldn't? Seems relatively simple, right? Implementing it isn't fun, right? Let's think about that. So if we go back here, I'm going to name this quick. In home, this is an async component. We already know that. Why do we have to do all this extra work? Also, what if I wanted to have something else here, like some header? And I want to show that sooner. What if I want to have more control in these ways? Right now, we can't. But with this new magic flag, dynamic I/O, we have a lot more power now. And even though it is magical, I think once it clicks, you'll see how much simpler it actually is. Now that we have dynamic I/O, what we've effectively done is we've told React and we've told Next, hey, when you see async, that means we're doing I/O. Treat that as dynamic. So now this piece is automatically considered dynamic. We don't have to import headers. We don't have to do anything else. This is dynamic simply because it's using I/O. And now it all just works as expected. We don't have to write additional wrappers. All we need is that loading state. And I could even delete this suspense. Works great. We don't get the header now because it's async. But what we can do now, which is even cooler, if I delete this, async function contents. Now I can put this under a, I'll get that. It already guessed for me. Ta-da. Now, Next is smart enough to ignore this loading state entirely and generate this component up to the some header call. So if we go back to my diagram, what we've effectively just done is move this line down. And now this part can be part of the static render as well. I think this is really cool. And where it gets even cooler is once you start involving other things like use cache. I'm not using use server here. Nice try though. Now, after the first load, it comes in instantaneously because use cache doesn't just cache data, it can also cache JSX outputs. So now when I refresh, I'm hitting refresh right now, it loads immediately. I think that is really fucking cool. But if it's using async to paint, how does it do that? There's a lot going on here. And if we go back to this code, hopefully you might be starting to see how this all comes together. The first thing that I really want to make sure clicks before we go any deeper is what dynamic I/O means. It's not some clever buzzword name. It's actually, I mean, it is clever, but it's really simple. What it stands for is I/O means dynamic. So when you're doing I/O, which means you're calling async await, that means that part of the code is now dynamic. And if we're painting your React components like I am here, that means these guys are red because these guys need to be rendered every request. But these can come from a CDN instead. These can be statically rendered ahead of time. These can be cached indefinitely and thrown around however, but this part has to be treated differently. Very clever. But what is this? What is this monstrosity? Why are we calling setImmediate twice? What are we doing? Here's where we're going to get a little bit deeper. As I mentioned before, there were a lot of these magic helper functions like headers and cookies that would paint a route as dynamic. Otherwise, it would be treated as static. You had to give Next indication of like, hey, this is dynamic, treat it accordingly. But not every dynamic task needs headers or cookies, and not every static task doesn't either. It's a really weird and arbitrary thing. And when you're calling external libraries, you're using other tools, it becomes really hard to reliably find all of these function calls and compose them with different libraries and tools. But doesn't that also happen with async await? Like, we can't reach into the library's code and scan for all the async await calls. We can't. But this isn't a compiler feature. This is a JavaScript feature. And this is when my mind broke. When I realized this is how it actually works, it all clicked for me. In order to truly appreciate this, we need to understand a bit about the event loop. There's a lot of really good content about the event loop, and I'm not going to sit here and just go over the whole thing again. I'll leave a link to this video in the description if you want a better breakdown. But the quick TLDR of why it matters here is async tasks go into the call stack, and when they get resolved, they get resolved. But when you call setImmediate, it immediately throws that task at the front of the microtask queue, which will preempt anything in the call stack. So now imagine that this pre-render code is rendering our app. Everything up until it hits an async boundary is just a traditional task being rendered synchronously. But when it hits those async boundaries, it gets thrown into the task queue. And the task queue doesn't get resolved until the current task is complete. But if you jump in front of it with the setImmediate, you get to skip all of those tasks that are running. So, app renders the synchronous parts, which is app, top nav, and home. These asynchronous parts, like the slow components here, those will get thrown on the queue. But since we call setImmediate right afterwards, it's going to jump in front of those other async things, and the abort's going to kill it. So the result, which is the stream that the prerender function gives you, is only going to have the parts that are static, not the parts that are dynamic, not the parts that are async, because those async calls are all waiting on the queue, and they get jumped in front of by the setImmediate call. It's so clever. It's using JavaScript itself as the way of painting these components. Previously, they needed a compiler that would go to each component and identify, is this one probably dynamic or probably static? And then give a bunch of these tools so we as developers could try to help Next understand what is or isn't dynamic. But wait, what about the cache stuff? Because I showed that use cache call. This is still an async function. How does that work? Good question. I'm happy I asked. If we hop into what was built here. So this part's admittedly quite obfuscated because it was minified. It's meant to be production code, not code that we analyze. But I want to make sure you guys understand how this works. This 7027, this is this component, contents. And the thing it does differently, because we put this use cache call on top, is it quickly checks the server cache to see if we have a value for the current inputs. And it defines these variables for what it's found from there. It defines this async function S, which is the component function. It's the code that we actually wrote, and it has the children here, which are using the JSX, like I showed you guys, the slow component guy. So that's inlining that there. But then here, the value L, which is what we end up returning and using. This is the actual output here that matters. We call this specific a.p function with 3 arguments: default, a hash, and this async function. So what the fuck is it doing? It's actually quite simple. It's checking the default cache for this function using this hash as the identifier to see if we have a value. And if we do, awesome. We use that value. No async is hit. The async only gets hit if we don't find a value first. This a.p function early returns before we get to the async part, which means when we hit something coming through use cache, it can be resolved synchronously. We don't have to hit an async wall if the thing is cached, which means that we can, via the use cache function, tell Next, hey, this can still be rendered statically. This can still be part of that partial pre-rendered cached output. What we've effectively done is told Next, hey, I know these are supposed to be red. Trust me, bro, they can be green. And that's really cool. The thing that was confusing with the model before, in my opinion, is that the functions effectively painted themselves dynamic or static based on all these weird esoteric rules that existed in the Next world. Now, synchronous components are static and asynchronous components are dynamic. And if you want that dynamic component to have these static benefits, explicitly call that out with the use cache header. It's super clever and simple and also very reliable because there isn't a bunch of magic hacks that empower this. In fact, they got to unhack. Remember the example here where I showed this headers? There's a commit here that Guillermo made, founder mode, where he deleted headers from there and added dynamic IO true. But there's another part here, which is we need a way to know when you call headers or cookies that this thing is dynamic. And I'll show you how they did that. Let's say I use headers in here. I'll import it from Next headers. Let's say I use the value, const header values equals, wait, it's a promise now. So if I want to header values dot get, I get an error here. Property get doesn't exist on type promise. Did you forget to use a wait? Headers is no longer a magic function that paints things as dynamic. This gets painted as dynamic because you have to put in a wait in front, which means you have to make this async, which means it's now painted. That's why, if you were curious, headers and cookies and these other helper functions became asynchronous. It's not because they're slow now and they need to be async. The reason is because the new model uses async and await as indicators that this is dynamic. So by forcing the headers call to be awaited, you have now painted this as dynamic. When Wyatt first showed me this code in the presentation, it broke my brain. And if you look at the replies to this tweet, it clearly wasn't just my brain. Okay, so it tries to pre-render and returns a Honda prelude. It's the stuff I see in my nightmares. This code is literally what I don't like about JS. This code makes people ask what theme you're using. Yeah. Seriously though, this is so cool. Like the idea of using setImmediate and the event loop as your method of figuring out what can and can't be cached is truly galaxy brain. It's unbelievable. And it's not like this stuff is coming in the future. This is a theoretical solution. This is a real solution that you can use right now. And I'm already starting to use in apps. And this isn't going to just affect Next in the React ecosystem. I talked to a bunch of other people like Ryan Carniato, who's hanging out in chat, and immediately saw ways to use this for some of the stuff that they're doing over in the solid and solid start world. There's a lot of cool potential when these things are discovered. And as much as we like to shit on React and Next for copying what everyone else does, this is proof that there is still real innovation going on over there. This is a novel solution to some very painful problems that lets us opt out of a ton of compiler complexity. And if your issue with React and Next is that there's too many weird hidden behaviors and too many magical things you need to know the names of, here you go. They're using JavaScript to solve it. In many ways, this makes Next.js the most JavaScript-y full stack framework because it's using JavaScript as its method of building these caching layers, which I personally think is fucking awesome. Curious what you guys think, though. Is this nonsense or is it as cool as I'm saying? And until next time, peace, nerds.